to geometry. I hope everyone enjoyed their early spring break. I don't know about you, but it was a little hard getting up this morning, it was a little slow, but starting to get faster, so that's good. Alright, today we are looking at 4.1 congruent figures, and specifically with triangles. So we've looked in our room in the past and we saw that the chairs have the same size and same shape, and that certain tables have the same size and same shape. So in our classroom we could say that the chairs are congruent to the other chairs, and that certain tables are congruent to certain tables. We can do the same thing with polygons, and these two shapes, these are quadrilaterals, and they're also called a trapezoid, but we just want to make some congruent statements. And so what we can tell just by looking at our diagram and what's given to us is that when you see this one mark and one mark, that means that we can say that AD is congruent and equal to ZY. And we are shown that with one mark and one mark. Alright, and then I can also say that AD, let me put a second line here, I can say that segment AB is congruent and equal to segment DW. Then let's look at our four marks. I can say segment BC is congruent and equal to segment WF. And I'm forgetting one more, I think on the bottom, right? So I can say that segment DC is congruent and equal, if I go DC, I would have to go YX. Alright, then the other way is that if we were to name our shape, and I went to, and I said that this was quadrilateral ABCD, right? Well, if I go ABCD, then I have to match it when I go to the other shape on the right. So angle A and angle Z, these are called corresponding angles, and we'll get into that in just 1 second. So I would have to say that this is going to be Z, W, X, and Y. And the reason why that's important is that these angles match up and they're congruent, meaning angle A and angle Z are congruent, angle B and angle W are congruent, angle C and angle X are congruent, angle D and angle Y are each congruent. And we have to go in order. So if I went BADC, I would have to go W, Z, Y, and X. And again, we can do that same thing where we look and see that all of these angles are each congruent. And this is known as corresponding angles. So I know that last unit we had two lines and two parallel lines and then cut by a transversal. Well, we're not doing that here with this type of corresponding angle. So we're not dealing with two lines cut by transversal. When we say the term corresponding angles in this unit, it refers to two angles that are each congruent. Okay, so just be able to know that we had corresponding angles last unit and it was referring to something else. This is different. And the same thing with corresponding sides, which is actually what we did right here. We listed all these sides that correspond, or that in other words are each congruent. Okay, so just know that these terms mean that. Okay, it means that they are each congruent. So when you see the term the corresponding, you want to think congruent. Alright, and then if we went CBAD, we would have to go which way? We would say X, we would say W, we would say Z, and we would say Y. Alright, move down below. They want us to sketch triangle ants, and they say that it's congruent to triangle bud, and we're going to list all congruent angles, list all congruent sides. next, they want us to list all congruent angles. Well, I can say that angle A is congruent equal to angle B, right? A and B are what's known as corresponding angles. They are congruent angles. Then I can say angle N is congruent equal to angle U. They are both 90 degrees. That makes sense. And then the last one, angle T is congruent equal to angle U. Alright, then the sides. Let's do this. I know that AN, so side AN is congruent equal to side BU. The hypotenuse AT is going to be congruent equal to hypotenuse BG. And then our base NT is congruent equal to BG. Alright, next we're asked to mark all corresponding congruent parts with triangle red and triangle AHP. Alright, well, let's look at what we have here. First, I'm going to put one mark underneath R and one mark underneath A. And the reason why I'm doing that is that since we're told that these two triangles are each congruent, that means these two angles are the same. I know that angle R and angle A are the same angle, even though it's been flipped upside down. Okay, then it's also true that angle E, I'm going to put 2 marks underneath angle E, is congruent equal to angle H. It's also true, let's put 3 marks underneath D, that angle D and angle T are each congruent. So that just kind of helps us keep things straight, okay? We know which angles are congruent. So, solving this again, I know that angle A is equal to angle R, and so I don't want to put angle A in here, but I want to get the actual measure. So let's work backwards. We have angle E, and so that means that angle H and angle E are the same angle, so I can put 68 degrees here because angle E and angle H are the same. Just like angle D and angle T are the same. And so angle D and angle T, I can put 70 degrees here. And then again, at the start, we were told that angle R and angle A are the same. So maybe let's put one arc and one arc to show these two angles are the same. And then using our triangle sum theorem, we know there's 180 degrees in all triangles. Therefore, this angle will be 180 minus 138. And so that would give me a 42 degree angle and a 42 degree angle. So measuring angle R is 42 degrees, measuring angle H 68 degrees, measuring angle A was also 42 degrees. Alright, then TA, if I go TA, see how I went last to first? I have to go last to first. So TA refers to DR. So it's equal to DR, however we need in exact measurement, and I said DR can be 14. Alright, then HA, I want second to first. Second to first is going to equal ER, and ER is going to equal, ER is 15. And then DE, we went last to first, so last to first would be TA. And TA is going to have a length of, DE goes last to second, and that means we have to go last to second. So this is not TA, it's going to be TH. There we go. Alright, so since it's TH, it's our base, and what is our base? Well, our base is going, 10, there we go. We have a length of 10. Alright, two triangles are congruent when all three sides are congruent, and all three angles are also each congruent. Okay, so when that happens, all three sides, all three angles, then we know that these triangles are each congruent. Theorem 4.1 says if two angles of one triangle are congruent to two angles of another triangle, then the third angles are each congruent. Now this is similar to our triangle sum theorem, and really we can just use common sense. Because if I know that I have 110 and 20, this angle has to be 50 degrees because there's 180 degrees in all triangles. Well, same as over here. We have 110 and 20, therefore I can put 50 degrees here. So what I just did is I used theorem 4.1, okay? And it's similar to our triangle sum theorem. They're not the same, but it is similar. Alright, now let's take this problem one step further. Are these two shapes each congruent? That's a great question. And at first, you might think yes. You say, hey, listen, all three angles are the same, and they appear to be the same size and same shape, therefore I would put yes. However, the answer is really going to be no, or you could say not enough information given. And here's why. If I drew an equiangular and equilateral triangle, I can draw this. That means all angles are going to be 60 degrees. I can draw a second equilateral and equiangular triangle and say all angles on the side are 60 degrees. And clearly these two shapes are not congruent because this triangle on the right is much bigger than the triangle on the left. So just because all three angles are the same does not necessarily mean all three sides are the same. So we would need to know side lengths. And then once we knew side lengths of both shapes, then we could determine if the two triangles are each congruent. Alright, we're going to do the same thing down below, except we're going to do a proof. And this is going to kind of be a long proof. We're going to try and squeeze everything in. So let's do our statement of reason column. And alright, before we start, and we're going to need 6 steps, but actually before we start, let's look at this. So here's our one big triangle, and they drew this line down the middle, and it ended up creating 90-degree angles, and it cut this segment CD in half. Okay, so what I know from what's given is that GN, segment GN is a perpendicular bisector. Okay, now again, how did I get that? Well, you know, GN was drawn down and it cut CD in half. That's where this term bisect comes from. And it created a 90-degree angle here and here, and so that's why it's also perpendicular. Alright, now that's neither here or there. This is just more, you know, it's good to see that this exists, but we're not going to use this in our proof. Okay, but it's just good to know that that's what GN is, a perpendicular bisector. We have a triangle that's been created on the left, and we have a triangle that's been created on the right. And what we're going to try and prove is that these two triangles are each congruent. Now, what we need in order to prove this, so our plan is we have to prove that all three sides are congruent. We have to prove all three angles are congruent. Once we've done that, we can then prove that these two triangles are each congruent to each other. Okay, so that's our plan. Let's start with what we know is given to us. And let's start with sides first. So I'm going to say that GC is congruent equal to GD. And how did I know that? Well, I know that because I have 2 marks and 2 marks. So that was given to us. Alright, then for 2, I'm going to say that CN is congruent equal to DN. And I'm going to put G here, which means given. And how did I know that? Well, again, we were shown a single mark and a single mark. So we've proven that 2 sides are each congruent. We need to prove that a third side is also congruent. And we can do that. Go ahead and put 3 marks with GN. The reason why I'm doing that is you see how GN is shared with both triangles. Okay, so what I can say is that GN is congruent equal to GN. And what allows me to do that is called the reflexive property, where you can say that anything is equal to itself. GN is equal to GN. It's equal to itself. It's shared by both triangles. That's always going to be true. Alright, so I've proven that the three triangles are each, or that the three sides are each congruent. Now we're going to look at angles. And let's highlight this angle and this angle. And so what I can do is, I'm going to say angle, let's go NCG is congruent equal to angle NCG. Okay, and what allows me to do that is that it was given to us. We have a single mark and single mark. Statement 5, I'm going to say that, let's highlight these 90-degree angles. I can say that angle CNG is congruent equal to angle DNG, and that's also given to us, which is G. Alright, then our last statement for 6, we want to prove that these two angles are each congruent. And you're thinking, well, it's not given to us. We can't use reflexive property because these angles aren't shared. But what I can use is this theorem up here, 4.1. And theorem 4.1 says if two angles of one triangle are congruent to two angles of another triangle, then the third angles must be congruent. Okay, so I'm running out of room here. Let's do this. 6. We're going to say that angle CGN is congruent equal to angle DGN. And the reason for that, 6 is going to be theorem 4.1. Okay, over to the right. Now, one other trick that we have here that we'll learn, which will make our lives much easier. What I can do is I can put a 1 right here. Actually, you aren't able to see that. Let's go to black. If I put a 1 right here and a 2 right here, then instead of listing this as GCN and GDN, I can just say angle 1 is congruent equal to angle 2. And that's so much easier than using 3 letters. Okay? Just like here, if I put angle 3 and angle 4, then on step 6, and here I have that angle CDN is congruent equal to angle DGN. I can just say that angle 3 is congruent equal to angle 4. And that's so much easier than listing this out. So we'll do that here because it's a shortcut and it's easier. Alright, next we're going to do a 2-column proof again, and this time let's change colors. So here's our statement column. We're going to come all the way down. Here's the reason. And just like last proof, we need to prove that all 3 sides, all 3 angles are each congruent. And so again, just because these shapes look congruent, we can't assume anything. We have to prove it. Okay, and not all shapes will each be congruent. Sometimes you'll do your proof and you'll find out that these 2 triangles aren't congruent. So let's prove it and see if it's possible. Let's start with sides first. I'm going to start with EC is congruent equal, if I go EC, I would have to go AC. And why is that true? Well, it's given to us. We're shown them. We have a mark and a mark, so it's given to us. Alright, now I'm going to put 2 marks at 4 and 2 marks at 4. We're given that these 2 sides are the same. So I'm going to say that BC is congruent equal to BC, and that's going to be given. And then let's put 3 marks at 3, 3 marks at 3. And what I'm going to say here is that DA is congruent equal to DE. And that's also going to be given. So we've proven that all 3 sides are the same. Next, let's go to the angle. Alright, for the angles, we have a right angle at B and D. I'm going to call this angle 1, and I'm going to call this angle 2. And I'm going to say that angle 1 is congruent equal to angle 2, and that's good. Alright, for 5, single mark and a single mark. I'm going to label this angle 3 and angle 4. And I'm going to say angle 3 is screwed equal to angle 4. And that's because it was given to us as well. Alright, and then last but not least, we have this angle inside here. Let's put 2 marks and 2 marks. And let's call this angle 5 and angle 6. I can say that angle 5 is screwed equal to angle 6 by vertical angle. However, a second rule that would work here is theorem 4.1. If two angles of one triangle are congruent to two angles of another triangle, then the third angle are each congruent. So we could also use theorem 4.1 as our reason as to why angle 5 is congruent equal to angle 6. Next, we have 8.1, the Pythagorean theorem. So this is review from before, but we know that if triangle ABC is a right triangle, then what I can say, let's get this straightened out, sorry about that. Then what I can say is that a squared plus b squared is equal to c squared. Now again, let's draw this out so we understand what we're dealing with. Here's our right triangle. Let's put angle A on top, angle B on the side, angle C for our 90-degree angle. Therefore, C is going to be our hypotenuse. That's always the side opposite our 90-degree angle. So our hypotenuse. And then let's put lowercase a for the side opposite angle A and lowercase b for the side opposite of angle B. And so we see that if we take this length a, square it, and then this length b, square it, it has to equal t squared. Okay, and that's true on all right triangles. So this only works on right triangles. If it's not a right triangle, it will not work. Alright, and then it's also true with its converse, that if we work backwards and say a squared plus b squared equals c squared, then the triangle is in fact a right triangle. So we're going to use this, the converse theorem for this problem and see if we can prove that 9, 12, and 15 form a right triangle. And if they do, if it's yes, then 9, 12, and 15 are known as a Pythagorean triple. That's three sides that create a right triangle. So we're going to take 9 squared plus 12 squared, and then it has to equal 15 squared. I get 81 plus 144 equals 225. 225 equals 225. And so that's going to be a yes. This is in fact a right triangle. Alright, let's try some other ones. Let's say you were given 3, 4, and 5. So we'll decide 3, 4, and 5 create a right triangle. Well, let's do some more. 3 squared plus 4 squared equals 5 squared. 9 plus 16 equals 25. 25 equals 25. Again, this is a yes. So we have 9, 12, and 15. That's one Pythagorean triple. We have 3, 4, and 5 would be a second Pythagorean triple. And then let's try a third one. So here was our first, our second, our third problem. All right, three numbers. Let's try 2, 5, and 6. So I get 2 squared plus 5 squared has to equal 6 squared. 4 plus 25 equals 36. 29 equals 36. This is false. So this is going to be a no. This does not create a right triangle, and it is not considered a Pythagorean triple. Alright, last one. Let's try 5, 12, and 13. And so when you try 5, 12, and 13, you get 169 equals 169. This is true, so 5, 12, and 13 would be considered a Pythagorean triple. Alright, working down below, we're going to reduce some square roots first. And with these, I would like to find pairs, so let's break this down to 105, and then 10 and 10. And I'm going to stop right there because I have 10 times 10 times 5, and for every pair I can pull out 1, and I would get 10 rad 3. Now the other way that I can do this is I can break up rad 500 into rad 100 times rad 5. And then hopefully we can just see that rad 100 is 10, and I get 10 rad 5. Okay, so this is much quicker, okay? But again, it depends on whichever method that you prefer. 3 rad 18, this breaks down to 9 and 2, and then 3 and 3. Okay, so I have 3 out in front, and I have 3 times 3 times 2. I can pull out one of these 3s, and then underneath I have 2, and I get 9 rad 2. Alright, the other way is take 3, and then that would be times rad 9 times rad 2. Rad 9 times rad 2 is rad 18, and then rad 9 becomes 3, so 3 times 3 times rad 2, we end up getting 9 rad 2. Again, your choice. Graphing. We're going to graph these problems as well. So y equals negative 1 for 1 half x plus 5. Rise 1, run 2. Down 1 over 2. And we draw a graph. When we graph using point slope form, we might forget how to do this. If you forget how to do it, just solve for y. Y minus 2 equals 3x plus 3. Add 2 on each side, and I get y is equal to 3x plus 5, and then I can graph this. But we can also graph using point slope form. Remember that it's y minus y1 equals m times x minus x1. So we're told that our first point, our xy point, is going to be, y is going to be 2, and x is going to be, since it's plus 1, it's the opposite, negative 1, and then 2. So negative 1 up 2 is our point, then rise 3, and run 1, down 3, over 1, and here's the graph. Alright, this graph right here is in standard form, so let's hide up the x and y intercepts, or let's hide up x and y and find the x and y intercepts. If I hide up y and just cross it out, I get 2x is equal to 8, which means the x-intercept is 4. If I hide up x, negative 4y equals 8, y equals negative 2, and I can graph my line. So that's graphing using x and y intercepts. Again, you could always solve for y. You could subtract 2x on each side, and then divide everything by negative 4, and you could have that same graph. X equals negative 2, then across the x-axis at negative 2, by a graph. Hope you had a great first day back. It will get better. Have a great Monday, and I'll see you tomorrow.